Good afternoon, everybody. We are here for ES 2110 statics. The date is Monday, January 22nd. And I wanted to have a quick gander over our syllabus, or excuse me, not our syllabus, rather our Moodle page, and then work a couple of problems. So if we take a look at our Moodle page, the first thing that you'll see is we were working through chapter 1. And as we said last time, the textbook for chapter 1 and some review notes and a couple of lectures are posted. So go through that information. Then the unit conversion handout is where the homework for chapter 1 will be. And then the unit conversion homework will actually be due on January 26th, which is this Friday. So if you have any trouble between now and then, let me know. But in the meantime, what I would like to do is to make sure that we have a chance to take a look at some of the problems. Now, I also kind of wanted to take a look at some of the more complicated problems, some of the compound problems, and discuss how you handle something like this. Because one of your classmates brought up a very good point, which is sometimes you may know a conversion factor. For example, it may be possible that you know that there are 2.54 centimeters in 1 inch. Okay. And if you do know that, you don't have to document that in any way. You can use that. The other point is that if you thought, or if you chose to use 2.5 centimeters per inch, that's also fine, as long as you show that to me on your homework. Okay. And the only point that I wanted to make about that is when you do your actual work, however many significant figures are in your conversion factor do not affect your answer. The data going in and the significant figures of that data affect the answers instead of the conversion factor. So what I would like to do is to take a look at problem number 2 on this, the rates, areas, and volumes, which says 550 centimeters per minute. And they want you to convert that. They ask, the conversion is to change that rate into feet per second. Okay, so getting back to our work here, what we need to do when we have a rate like this is, now, if you go online, you'll be able to see there is a conversion factor directly from centimeters per minute to feet per second. It's really not okay to use that kind of a unit unless it's very well documented. So what you really want to do here is convert centimeters to feet and then convert minutes to seconds. So let's start with the length, or the numerator. And we know that there are 2.54 centimeters per inch. And we further know that there are 12 inches per foot. Okay, so those two will get us from centimeters to feet. Minutes to second is a little bit easier. There is 1 minute is the same amount as 60 seconds. Okay, so the reason that these are called unit conversions is because a unit is anything that has, the way that we talk, we're converting the units, but we're converting based on a situation where the numerator and the denominator of our conversion factor are physically equal to each other. And so even though it doesn't look like it, when we take 12 inches and put it over 1 foot, 12 inches is the same physical distance as 1 foot. So this number actually has a value of 1 in terms of dimensionless length. So as long as the amount on the top and the amount on the bottom are exactly the same, we can do that and we can convert our units. All right, so let's take a look at 550 centimeters per minute. The first thing I want to do is to convert centimeters to feet. So I look at my first conversion factor, 2.54 centimeters is equal to 1 inch. Since my centimeters is in the numerator here, I want it to be in the denominator in my first conversion factor, because then we know that if you have the same thing in the numerator and the denominator, they will cancel each other out. All right, the next thing I want to do is convert inches into feet. There are 12 inches per foot. Once again, inches is in the numerator. So I want to put inches in the denominator, so those units will cancel out. And inches in the numerator cancels inches in the denominator. So I can see that in terms of length, I'm left with feet. Okay, now I need to work with time. 1 minute is 60 seconds. Here, minute is in the denominator. So I put 1 minute in the numerator, divided by 60 seconds in the denominator. Minute cancel out. And you can see that what I'm left with here in terms of units would be feet per second. All right, so numerically, what is the value? Well, on the top, I have 550 times 1 times 1 times 1, which is just 550. And in the numerator, I have 2.5, or the denominator, pardon me, 2.54 times 12 times 60. Okay, so basically, find my calculator. I didn't bring my calculator today. Did I bring my phone? Yes, I did. There we go. All right. So if I do the math on that, put this right here so you can see it. I would take 550, divide by 2.54, divide again by 12, and divide again by 60. And the number that my calculator tells me is 0.3007436 or 44. All right. Now, that is correct, except the fact that my data went in 550 without a decimal point has 2 significant figures, right? If it was 3 significant figures, it would be written like this with a decimal point. If it was 4 significant figures, it would be written like this, okay? So when you have trailing zeros, if the last zero does not have a decimal point, it is not significant. That means I need to write this answer with 2 significant figures, which would round to 0.30. So the final answer is, and it doesn't matter, you could say 0.30 or 0.30 feet per second. And that's the final answer for that problem. All right. So the next one that I would like to show you is when we have an area or a volume. All right, let's take a look at 27 square meters into feet squared. Okay, so the first thing, do I have that shared? Yeah, I do. Okay. So the first thing that I would do is I need to convert meters into feet, right? So if I look online, I know at the end it's 0.3048 meters is a foot. But if you needed to look that up, let's say meters per feet, you'll see it should be 0.3048. All right, so I should share that screen just so you see what I did. And this is valid. You are hang on. It's a weird thing. Here we go. Let's pull that up. And then we'll share it so you can see. You are always welcome to use conversion factors from the internet, especially for base or close to base units. So 1 foot is 0.3048 meters. All right, but so the problem becomes, not the problem, but the thing that, well, problem in engineering doesn't mean it's a bad thing. It just means we're going to work it out. So we have 0.3048 meters per foot, but we're dealing with meters squared. Well, what that means is that if we take the quantity 1 foot and square it, and we put that over the quantity 0.3048 meters and square it, that I still have a value of 1. But the trick is we have to square both the unit and the numeric value. All right, so when I work this out, I get 1 foot squared over, the answer is 0.3048 squared, which is 0.0929 meters squared. That's a conversion factor that I will use. All right, 27 meters squared times 1 foot squared over 0.0929 meters squared. Meters squared cancels. So I take 27 and divide it by 0.0929. I might have a reciprocal key here. Yeah, I don't. All right, that's okay. So clear. So I take 27, divide by 0.0929, and the answer is 290.635 feet squared. All right, now the only next thing we have to do, 27 meters squared has 2 significant figures, so we need to write this with 2 significant figures, which is 290 with no decimal point, and that's the final answer, right? So this is just sort of the method of making everything work. And I believe that in your work with our conversion factors, that the rest of these will make a lot of sense, because most of them are just, you have to check, for example, like here, what is a centigram? Well, in the metric system, centi always means 100. So we're going from a centigram to a milligram, from 100th of a gram to 1,000th of a gram. So the prefixes always work identically. Now, let's take a look at these problems, numbers 1 through 5. And I'll do one of these, and then we will call it a day, and you guys get to go work on your work again. So let's see what we have. All right. So when we talk about the acceleration equation, there are a couple of different things, but let's talk a little bit about the concept of acceleration. Acceleration is the time, or it's the rate of change of velocity with respect to time. So we can talk about an average acceleration. Well, let's do this. If distance is x, velocity would be the first derivative of position or distance with respect to time, and acceleration would be the second derivative of distance with respect to time. That also makes it dv dt, okay? It's a couple of other things as well. So for example, if you realize that velocity, it's another one. I won't get into that right now. This is enough. Okay, so let me come over here and take a look at one of our acceleration. A rabbit changes speed. Changes speed means acceleration, okay? The other thing is acceleration can be positive or negative. It is positive if either you are increasing speed or you're decreasing speed in a negative direction, either one. So acceleration or deceleration is decreasing your speed or increasing it in a negative way. So deceleration is generally used to mean your speed is decreasing, but there are 2 different ways that it can be negative. So it's just important to keep that in mind. All right, so if we take a look at the problem again, and we see a rabbit changes speed as a dog chases it, accelerates from 1.2 meters per second to 3.4 meters per second in a time of 5 seconds. What is the rabbit's acceleration? All right, well, if we look at the equation here, we can say then, if acceleration is equal to dv dt, that it's approximately going to be equal to delta v over delta t. Okay. And here, this would be v2 minus v1 over delta t. v2 is given in this problem as, I think, 3.4. Come back over here, look at my sheet. 3.4 meters per second. And v1 is given as 1.2 meters per second. And my delta t is 5 seconds. Okay. All right, so there's my data. So that means acceleration is approximately equal to v2, 3.4 minus 1.2, which is v1. That's in meters per second, divided by 5 seconds. And if I look at that, 3.4 minus 1.2 divided by 5 is 0.44. Acceleration is approximately equal to 0.44 meters per second, or meters per second squared, which is a unit for acceleration. All right, so if I look at my answer, this has 2 significant figures, this has 2 significant figures, this really only has 1. So I would accept this answer, but the more accurate, the more correct answer would be 0.4 meters per second squared. But either of those would be fine. The only thing I wouldn't accept is if your calculator said, I mean, you're not going to lose full credit, but if your calculator told you 0.44296485 and you wrote all those out, you know, so there we go.
We did number it. Yeah, 557.
Yes. Hey, let's take a peek here, what you're saying.
Is it right in this problem?
Right, what did I say? I don't even know, 550?
Yeah, over 1.
Okay, to feet per second. Well, we have to convert feet, and then we have to convert seconds. So what was your question?
So,
Did I?
so we did it 2 seconds.
Oh, yes, you're right, Ethan. You are absolutely right. Technically, this should be 0.3 feet per second. Very good. Good catch. Excellent job. Yep. Very nice. I was just looking at my answer here. No, I'm sorry. I'm going to have to retract my answer. I'll show you why. Okay, because the only data that we have is 550, right? This is actually a conversion factor, so we don't base on that. So we're only based on this. So it is, yeah, it is. Yep. Now, if you'd written it this way, I would not take credit off, but the best answer here would be 0.30. Yeah, you had me convinced though. That was a good one. So, all right. So do you have any other questions about the homework? All right. Well, let's call it a day then and just say thanks for not having a long class. So we will meet again next Monday, face to face, and the homework will be due Friday. I'll have it graded and then we can talk about it and we'll get started with chapter 2. But I want to reiterate, if you have any trouble or if you have any questions between now and next Monday, get a hold of me. We'll schedule an appointment and get you squared away. All right.
So, just I use an app called Cam Scanner.
Yeah.